Hello, everyone. Spot is on. Thank you for joining us, and I hope everyone is doing well and enjoying the summer and keeping healthy and safe. This is Samar Safihar from the Faculty of Science at the University of Manitoba, bringing you the 10th talk of the series Spot, which was created to bring our community together during these difficult times to engage our students and to connect you with our friends and family, at least virtually. Um, we also want to connect with our alumni, and today's talk is by Kate Stewart, U of M alumni, joining us from her home in Austin, Texas. Before introducing Kate, I would like to begin by acknowledging that we are in Treaty 1 territory and that the land on which we gather in Manitoba is the traditional territory of Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. The talk will be 20 minutes long, followed by a question-answer period that's also 20 minutes long. To ask your questions, go to slido.com, and the event code for today's talk is D411, D411. You could choose to have to show your name or remain anonymous. I'll be moderating the questions, um, and you will be able to see the questions on your screen. And if there's a specific question that you really like, give it a thumbs up, and it will rise to the top and gets asked first. So now it's my pleasure and honor to introduce our speaker for today, Kate. Uh, Kate, like I said, is joining us from Texas, but she's a Winnipegger. She grew up in Winnipeg. She got her Bachelor's of Science in Computer Science from the University of Manitoba. Then she did her master's degree in computer science in the Faculty of Mathematics at Waterloo. She has worked on different continents. So she worked in Canada, then she moved to Australia, and she's now in the States. And she worked from startups to Fortune 500s and currently working for a nonprofit. She has managed teams and software developers working on open source in the US, Canada, the UK, China, and India. She joined the Linux Foundation in 2015, where she currently serves as the Senior Director of Strategic Programs. The Linux Foundation is dedicated to building sustainable ecosystems around open source projects to accelerate technology development and industry adoption. Linux is also known to be the go-to infrastructure supporting the world's e-commerce leaders, including Amazon, eBay, PayPal, Walmart, and others. Kate is on the leadership team, directing the strategic programs around open source license compliance and supply chain software transparency. Her current challenge is figuring out best practices to make embedded open source software dependable in safety critical applications. Kate, thank you so much for joining us today. Over to you.
Thank you so much for the nice introduction. Really appreciate it. I kind of feel I'm a very lucky person in some ways, in the sense that I've got a job that's just been, it's really exciting that all the things I get to see that's starting to emerge, and all the innovation that's happening with open source. When I started off, I've been now in basically computer science, working on computer science related projects and programs and so forth for over 35 years. And that's me in my co-op class. I'm at the back because I'm tall. And it's kind of interesting to see the changes in demographics and what's been happening. And I'm still in touch with several from my co-op class. So I hope the students that are there keep in touch with theirs, because it's a wonderful network. One of the things I've been learning, though, in the last, since about 2004, is how important open source is and how it's really key for the innovation. It's a foundation for these innovations that we're seeing just coming up day after day. Right now, 99% of the code bases that were audited by Black Duck, which is a scanning tool, contained open source, and of the code that was in that they scanned, over 70% of it was open source. So these open source projects are being reused, which is the big value of them. And other reports that are coming out in the last year, they're seeing double and triple growth in these components. All you have to do is look at GitHub and look at how many repos are on GitHub to get a clue that it's not slowing down. It's easy for people to share. And with that sharing and that building together diverse opinions, we're getting some really cool things emerging. In the last month, we've seen the SpaceX rocket go up to the space station with the Dragon capsule. There's Linux running on the rocket. There's Linux running in the capsule. We're seeing actually the whole rise, what's happening with the autonomous cars, as well as the automation of a lot of the infrastructure. Autonomous driving is one part, but there's, what's happening with the charging stations, what's happening with the sensors. All of this ecosystem is coming together, and it's running Linux and it's running other open source. And I don't know about you, but when I can't, I'm too old and blind to drive. I want a car to be able to take me around as opposed to being sort of stuck in one place. Thank you very much. So I want this technology to be safe in the next 10 years. Thank you. So we're seeing open source in these places very pervasively throughout the ecosystem. And with everything that's been happening right now with the whole COVID scenario, one of the things that's been quite exciting for me is seeing the rise in open source ventilators. And people are basically making the source code behind some of these ventilators available, and people are, collaborating worldwide to make more options available to people. So you can sort of see that open source is already being used in applications we consider safety critical. But the challenge now becomes, how can we be confident that the software based on open source is going to be actually dependable when people's lives may depend on it? I started getting interested in this problem actually in my co-op work term in some ways. When I look back at it, I found out that some of the software I was working on could impact people's lives. I did one of my work terms at St. Boniface Hospital working for Dr. Harvey Schipper, and he was busy pioneering how we could do remote cancer protocol management so that people in northern Manitoba didn't have to fly down for 2 days to Winnipeg, have their treatment, and then try to fly home when they're feeling so horrible after the chemotherapy. And, I'd have to walk in through the hospital, through the oncology department, seeing people sitting waiting for their treatments as I went into my back room to go and work on the programs and work on the design. And so, these sorts of things leave a memory. And, but you felt that it was important to make sure you had high quality, you had the right testing, and that you had the redundancies and things that are necessary, and the right analysis is done, so that the doctors who are entering data can, make sure it's relayed accurately. There was checks on the fields to make sure there was no minimize the finger fumbles in the entry and things like that. So it was one of those first work terms. The other recent influence I had is I was lucky enough 2 years ago to be in at the ICSI conference in Gothenburg, and Margaret Hamilton was the keynote speaker there. And she's one of the people credited with developing the term software engineering. Now, she worked on the Apollo 11 software. She basically wrote the software that has run on the moon. And she did a lot of testing and some of the testability. And she tells some really great stories. So if you have a chance to catch her keynote from 2018 ICSI in Gothenburg, I highly recommend it. But one of my first memories as a kid was being told to watch, the men on the moon landing, and being brought down, black and white TV, on it goes, and you're watching the men landing on the moon. And it would have been such a different world if someone hadn't programmed their software to make it work right the first time, because as she was saying in her keynote, it was man-made software, lives were at stake, and it had to work the first time. So how do you start making sure that you do the right level of analysis, testing, and conformance? This was sort of the start of where a lot of the safety standards have come from, was that time period, and moving forward in terms of codifying, okay, how do we develop software? How do we come up with the requirements? How do we test the requirements? How do we make sure it's effective? And so through those years, various safety standards emerged, and they were emerging around the notion that you have to be safety critical. and they assume to certain methodologies. And the challenge then is, how do we deal with open source? The rate of change is so different. So at the Linux Foundation right now, I'm involved with several projects, and two of them are really focusing on how to go after safety with open source. On one side, there's Zephyr, which is very, very small. It's an RTOS, and it's sort of like, for the 512K and less type of space. And then we have Linux, which it doesn't get smaller than about 2 meg these days. And so both projects are looking at trying to go after safety certification, and they're taking different approaches. And so I'm just going to give you a little bit of a flavor for the two different approaches that are being worked on right now. So Elisa is enabling Linux in safety applications. The key here is Linux has pretty much grown to be one of the most important software projects in the world. It pretty much has a lock on most of the markets, and even in embedded, it's about 69% based on the most recent data I've been able to find. So it's pervasively there. It's in your cell phones. It's around you almost all the time. And you'll be seeing a lot of it in new cars coming in too, for that matter. Automotive grade Linux is there with Linux working on your dashboard. So Linux is there. It's being used in safety critical. How do we make sure that we are safe when our systems are going to be safe? And the heart of this one is understanding how you need to understand your system sufficiently, and you need to understand how Linux is interacting with your system. And the analysis has to revolve around the interactions of Linux with the system, and then what mitigations and what could go wrong, and what analysis has to be taken. So the difference between a Linux development when we do it for safety critical in general applications is just how you're using it. And it's that extra level of testing and the interactions and the analysis that needs to go on. To give you guys a feel for the rate of change, Linux actually has about 9 changes per hour going into the code repo as commits right now. And there is 1 commit per hour of bug fixes going into backports from Linux for fixes that have gone upstream. So that type of change is not something that you can sit there and do an agile, a waterfall model against reliably, because the most sound things, they're all just bugs as far as the kernel developers are concerned, and they need to be fixed. But that's where Linux is coming from. So it's been in use for over 29 years. How many other software projects can you say have been that way? And there's processes for continuous improvement. There's prerequisite quality. There's the process quality. All these things that are elements that the safety standards are calling for are there, but they're not in the way that the safety standards are used to seeing them. And so, how do we make up what's available and visible from the evidence of what's there in a way that the assessors will understand it? And then, where are the gaps, and how do we fill them? What do we do with the community? So that's what this project's trying for. Its mission is to come up with a common set of elements, processes, and tools that can be incorporated into systems and help you make the assessment. So the path forward we've got, these gaps, right? What's happening in the safety standards, they call for certain things, and we're trying to look and see what's happening in the kernel process, making them visible, and sort of writing in a way that the assessors will understand these evidences that say that things are there, or what coverage is like, and things like that. And then we're also taking a look at the Linux kernel community and starting to look at the areas where there's interfaces that might need to be looked at inside a system. So those are 2 of the work groups. And then there's 2 work groups right now, but there could be more. One of which is the medical devices working group, where we're looking at the open source ventilators you saw before, as well as the Open APS program, which is an artificial pancreas system, where basically they've used a bug in the system and hooked up a glucose monitor to an insulin pump with a Raspberry Pi in the middle. And these hobbyists have basically come up with their own algorithms to help even out their blood flow and so forth, like the glucose levels in their blood and so forth. And because it's done as a hobbyist, there isn't liability issues, and it's all open source. Therefore, we can all go and look at it and do the analysis. The other one group that's working is an automotive working group, because we've got a lot of people in the car industry who are trying to figure out how to solve these problems. They're looking at the EDAC system initially. And we can pretty much spin up in this group anyone who's got a good open source application that does not require you to sign an NDA, and there's other people who want to collaborate. They can sort of join this, do the analysis. We've been looking at working with the SDPA analysis from Nancy Levinson and the medical devices anyhow, to help break down the problem till we get to the Linux boundaries, and then the safety architectures analysis will be taking in helping to pull the argumentation together. So, we're not going to be making Linux safe, quote unquote, but what we are doing is helping you figure out how to use Linux to create a safe system. And basically, there's a bunch of people who all have the same problems. We're all trying to work together. If you want more information on Elisa, these are the, there's elisa.tech is the link, is the website, and you can find the rest of it from there. The other project I want to talk about is on the other end of the spectrum. It's another OS. It's called Zephyr, and it's being used when, quite frankly, it is just, it's on little sensors, very resource constrained things that have to have their power last for 6 months or more. It's being used in hearing aids. It's being used in wearables. There's a lot of interesting little devices emerging right now where it is being used for distance monitoring in the COVID situations. Like, so the distance dogs, I know 3 products that have emerged in the last couple months that have Zephyr inside that are doing, measuring distance and then recording information and then basically having a control structure around it to say, record the information without recording all the personal stuff that your phone would, for instance. So, industries are looking at things like that. But it's a neutral governance like Linux is. It's got a license that's friendly for the embedded ecosystem. And we started the project knowing that we would go after safety as well as a goal here. And we started off with security, and we had a security team right from the start. And now we've basically, in the last year, we've been working on putting the safety team in place and gradually working our way out. Because Zephyr is so much smaller, it's more amenable to the things that the safety assessors are looking to see. Quality in the project has been a goal of everyone that's been coming into the project. The code base is very clean, it's very friendly, it's very familiar to a lot of Linux developers. It's not Linux, but it is uses elements of Linux, things like the device tree, things like the kconfigs, statically configuring what you want, structured hierarchy. It has maintainers there that sign off on the changes. And we've been wanting to, the code's been very clean on its licensing, and it's also been through a lot of covariety scanning, analysis tools, and so forth. We're actually working towards moving the code base into some coding guidelines. And the code base is going to be going through MISRA, which is something that's more familiar to the assessors. It's actually a pretty full OS in terms of stack, and you're just basically compiling in what you need statically. But what we were trying, so there's a lot of applications people can build with it. There's about over 200 boards in the repo right now, and the rate of change in this one is over commit an hour in this one too. When we started the project, we had the idea that we knew we were going to be doing development when we wanted to have open source development dynamics. So we kept that we've kept that little development repo where it's working at that 1 change an hour. But then we needed to create a way to sort of say, okay, this is what we're going to support. And if you're building products, you want to have something you can base on, and you just know that the bug fixes will come, and you don't have to have that whole rate of change. And so we created a long-term support. We planned on this right from the start, and we've been executing to that. We put out our first LTS last year, and a subset of this is what we're going to be taking through the audit process. And what we're doing there is we're going to be going after 61508, and it's the subset that we're working with. And we're taking smaller and submitting the smaller section. So we're looking at just subsets of Zephyr, and we're hardening the code, and we're pulling the full testability, trace matrices, coverage matrices, and so forth together to go after the standards in the way that the assessor is expecting. And we can do this in this project because the developers knew that we were going after this as a goal right from the start. And so we've got a team that's busy working to assemble the the documentation. We'll be working with outside assessors, and we'll be going through a formal assessment of a product with Zephyr. And that's what we're looking at probably doing next year. Right now, we're basically getting the whole code base moved over to the coding guidelines, and we're prototyping some ways of doing the tracing of the requirements analysis inside the code and being able to keep them up in sync together going forward. So this is sort of what Zephyr is trying, which is a different approach than the Linux side is. But Linux is 29 years of history, and Zephyr has 4. So if you're curious about Zephyr, you can find more information on these sites. The repos are public. The mail lists are there too. Anyone can join, anyone can look at it. Same with Linux. So anyone's interested in going and looking and collaborating, you're welcome. And I guess in summary, open source collaboration is driving so much innovation. It's one of our strengths. And the safety standards give us a factor to consider, which is their strength. And so by putting these two things together and figuring out how we can bridge the gap between them, we can hopefully get something that'll emerge that will be able to be used by, give us all confidence such that when we have to depend on the software to run, it will. And with that, if there are any questions, happy to take them.
All right. Thank you so much, Kate. Also for sticking to time. That's very interesting talk. We already have some questions for you. The first one is actually more of a comment from Razi. I don't know if you remember. Hopefully you do.
Yes, I do. I remember. I read it.
So this is Razi, Pat and Peter's son from Winnipeg.
Mm-hmm.
So, too bad you can't see him back. But
I know. Actually, I was just talking to Peter and asking him last weekend, okay, is the co-op program still in place? And he said, yes, it is. It's all doing fine. So as he was on his way to the lake. And so I wish I was in Manitoba being able to go to the lake right now. No question. It's much better than being in Austin.
All right. Well, right now it's thundering. So it's very bad weather at the moment. Otherwise, it's been great. Wonderful. The next question from Adam KS.
Mm-hmm.
It sounds like this is my own son. What types of job opportunities are there in your field for future graduates like me?
Well, I'm afraid I don't know much background on you other than maybe you're a student here. But the computer science I've found has been a very good starting point for many things. And there's so much innovation that's going on. If you're looking for how to sort of get involved in open source more, it's literally just find something you're interested in, start contributing. Submit issues initially, submit bug fixes, start thinking about what features you want to improve it, make suggestions, start discussing it. Open source thrives by having people participating. There's also a lot of mentoring programs that are out there. Linux Foundation has a couple in Community Bridge where they can get paid internships to work on open source projects, and then people will find mentors if you're interested in working on something that is there. So you do it for open source. You get involved by doing. There's no shortcut that way. And there's a lot of industries that are in the embedded space working on problems like the automotive ones and power grids, critical infrastructure. So being familiar with the tools that they're using and moving to, I think, helps with getting jobs.
Right. So that's great advice for students at the university. But Adam must be, if this is my son, which I believe it is, he's a 13-year-old. So what advice do you have for kids actually watching you?
Advice for kids is the same. Anyone can log on, look at a GitHub repo, and start to figure out what's going on and pick up some books on programming language. Or if you don't feel comfortable programming, try doing the testing for them. People are always needing people to do testing and help make things right, and then filing issues. So just dive into something that you think is interesting or that needs help, that you want to help. And I think if you see someone that needs help and you give them help, they try to help you in return. It's very nice to, there's the right parts of the ecosystem are just wonderful. They're delightful people to work with. Like I say, I very much enjoy my job.
Great, thank you. And Adam, try to do it independently first. But okay, the next question from Annan. Annan, how do you think co-op impacted your career?
I think it was probably one of the best things for my career. Was being in the co-op program. It had just started. I think I wasn't the first year, but I was probably the second or third. I can't quite remember. And what was happening is I pretty much worked at different places each time. And it gave me the sense that I could adapt to different circumstances and different jobs. And there was interesting challenges in every place. So I didn't have a boring co-op season at all. And that trend has pretty much kept straight through for the rest of my career. It sort of gives you the confidence to know that, okay, if I buckle down and work hard, I'll figure it out. And that's what co-op gave me.
Great.
And it also helped pay me my way. It helped me pay my way through university too.
Yeah. Great. Thank you. Yeah, I mean, our co-op program grew a lot actually.
Really?
Yeah, it's been getting more popular and stronger.
It's a great way for students and for industry to basically sort of experiment. As I've gotten older, I find a lot of the open source projects, like I do a lot of work with Google Summer of Code for a couple of my projects, and we have people, want to pass it forward, pass it on, right? And so a lot of people are willing to do mentoring in these things, and the fact that Google basically provides funding really helps a lot of the unfunded projects move forward. And I've got a couple of those I work with as well, like SPDX. So we have got 4 GSOC students working right now, and then 2 coming from the mentoring program from the U of M. And that's what's moving the project forward, because all of the people who are there are sort of senior and have, day jobs and night jobs type of deal. And but spending a few hours a week doing mentoring and then knowing that things that you care about is moving better, it helps everyone.
Great, thank you.
Which hardware platforms am I using in the prototype work that's going on? Well, Linux is actually pretty much running on most hardware ecosystems, and Zephyr is running on a wide variety of hardware architectures as well. So those ones, and they're more than prototypes actually, both Linux and Zephyr are being used for products. So as we're sort of working through the systems, it's going to be, whatever the community wants to work on, and we sort of move it from that way. And it looks like Samar's frozen on her end, so I'll do my best to going through the question.
I'm back now. Sorry, things froze from my end. I don't know if things were okay from your end, so I'm not sure if you answered the question already.
Yeah, so they're asking which ones we were prototyping. Basically, a lot of the innovation right now is going in the Zephyr type of projects and so forth. We're seeing a lot of work going on in the ARM space, so 32 and 64-bit ARM, and then the RISC-V. There's a lot of people interested in taking and customizing the hardware, and RISC-V, being an open hardware ecosystem, lets you have that level of customization, optimization that makes certain things more power efficient and time efficient. So we both Linux and Zephyr work on that whole range.
Okay, great. So I'm glad things kept going for you. I'm worried with this weather we might lose power, but you won't lose power. Let's accelerate. So the next question is, can you share a story of how you persevered during the hard times in your career?
Oh gosh, yes. So when I just got out my master's, and I managed to arrange for a temp visa over in Australia to go work in Australia. And I, done my networking beforehand, and I had a job potentially, job lined up, and I landed in Australia. And I called the person who's going to be my manager saying, hey, I'm here, what's going on? And she says, oh, they let me break it to you. The company you're about to work for has been hospitably taken over. You're out of a job. So I just come out of my master's. I didn't have a lot of funding, and I was over in Australia. It's like, okay, now what do we do? Well, luckily, Veto, who was actually from Winnipeg as well, she said, listen, I've got a spare room. You can come stay with me until we both find jobs. And so I ended up spending up my 6 months with her. And the next Monday, I walked around the neighborhood in that area and just started knocking on the doors and saying, hey, I had my resume with me, and, said, hey, do you have any openings? And then one company's Intelligence Proprietary Australia said, oh, you saw our ad in the paper? And I went, no, but here's my resume. And they were busy doing programming for an inventory system for the Royal Australian Navy. And so I said, listen, I'm here for 6 months. And they brought me on, and I had I was busy working programming there. And so I had to learn a few new systems, but no problem. We'll figure it out. And you just keep persevering and, just keep trying.
Great. Wow. Inspiring story. Those 6 months could be 6 months of COVID now, right?
Oh, yeah, definitely. It's right now, it's sort of like, okay, a lot of my job is talking to people and meeting people and trying to figure out how we can all collaborate together. And so coming up with new mechanisms right now is something that we're all trying to figure out.
Right, great. Thank you. A comment from Razid, the co-op is even more stronger at, say, top in Canada.
Whoa, way to go. You guys got it. That's great. Like I say, it really is. The co-op programs are probably the best way to basically work through an education, because you get a bit of that hands-on experience to make context, to make things make sense.
Yeah, and it does help students mature at the same time as well, right?
Definitely.
Having this work experience
Mhm.
early on. Yeah. All right. Next question from Janet. How secure is your Zephyr operating system, or I guess how prone is it to hacking?
Well, actually, we've been starting pretty well. We actually had the NCC group do a deep analysis on us, because they'd had customers asking about that same sort of question. And they found 23 vulnerabilities. And they let us know, and they let us know under embargo. And we had them all fixed very quickly. And then we also let our people who were our members and others who are working with Zephyr in products know about these things. So we followed the proper process. Zephyr is actually one of the few open source projects as a CVE numbering authority. So, you start seeing these little CVE numbers when you start hearing about bugs. Zephyr actually can issue them. So we take it very seriously. There's a program at the Linux Foundation called the Best Practices Badge. It's a Core Infrastructure Initiative Best Practices Badge. And this came about as a result of the Heartbleed and some of these things. And they did a survey to figure out what best practices were in the industry, and they created a badging system. Zephyr is one of the few projects that's actually gotten to gold. Both Linux and Zephyr are gold, and Zephyr got there before Linux.
Great.
So we're pretty secure, and we've got security. We've got a PCERT team that basically responds to any vulnerabilities that are reported, does the analysis, investigation, works with the community, the rest of the community to get the fixes in.
All right, great. Last question from John. What might be opportunities in citizen science to contribute in your field?
Ooh, I'd say start attending. Not quite sure what the definition of citizen science is here. Can you what is meant by citizen science in this context?
So I'm an astronomer, for example, and in astronomy we have a lot of projects where you involve the public or people outside your field in the kind of science you're doing. So, for example, if we have tons of images of galaxies, we get a lot of people involved into looking at those galaxies and helping us classifying it. So, involving the public in science.
So that's something like, for instance, I was doing when I was at Ubuntu, and we basically had a community volunteers basically testing the next release of Ubuntu before we basically just deployed it. So testing and bug fixing, taking the software people are writing and actually saying that it's actually behaving as it says, and if it isn't, filing the bugs and letting them know. So if there's applications you're interested in, going and working with them and then helping them make them hardened and file bugs, and then so you get interested and then submit fixes too.
Right. I mean, you post things on GitHub as well, no? Like some of the software, so they can contribute.
Yeah, the SPDX project has tools. That's one that isn't a lot of funding, and we're doing some things. But Zephyr is completely open up there, and if you go and look at Zephyr and you see a problem with the documentation, send a fix in, or at least let people know, hey, this doesn't make sense. Can you please clarify it? And then someone in the community will pick it up and work on it. Or if you want mentoring, someone will probably just say that, hey, I'll help it. Someone has to talk me through it.
Right, but do you actually pose problems to the public? Like, do you put out things that you would hope the public to help you so they know what to contribute to? Exactly.
Well, you'll find in the GitHub repos, you'll see help needed tags that people will put on issues where they're looking for someone to help them fix something or do something. And a lot of those are good sort of on-ramp issues to bring you into the community. So if you're interested in working in programming, or you're interested in working in documentation, or we're going to be doing a lot of analysis, documentation, and so forth with Elisa, joining in the meetings, listening to the meetings, figuring out what's happening, and seeing what's interesting to you.
Okay.
Because all the diverse perspectives all make things better.
Okay, great, thanks. Well, actually, more questions and comments are coming still. So the next one is a comment from Helen, who also knows you. Hi, Kate, from Helen and Glenn.
Excellent. Okay.
Did you see an increase in participation when COVID-19 caused people to be quarantined in their homes?
Yep, I did. Very much so. Actually, what's kind of interesting is if you look, Linux, the 5.8 release of Linux started happening through the COVID cycle. And it's pretty much public now that this is the second largest ever influx of new patches and features into Linux is what has just got accepted into 5.8. And so, yeah, I think there's a lot of people sort of using their spare time when they might have been out doing something, now sitting inside and working on problems and things that they think are interesting.
Great. Thank you.
I
guess a lot of people are excited to be seeing you today. The next question is from Aaron. What do you think is important for an open source project to do to help establish trust in the software or gain a wider adoption?
Transparency and fairness. A lot of the projects that I've helped work on setting up, we pay particular attention to the governance of the project right from the start to make sure that we can have a fair playing field and that there's an on-ramp from anyone in the community to make their way into the project and be an effective contributor. And so designing the project so that people don't have locks on things and that, if someone's motivated enough, they can be there. That is important. The other thing for me that's important is something that we've been sort of trying with Zephyr is to make sure that we don't have too many elephants, so to speak. There's a concept in software engineering, or metrics at least, about the elephant factor, and wanting to make sure we have a diversified, distributed set of participants interacting in the software. Building that up and then having that trust through the transparency, that's what attracts people to do it. And so, if the license you contribute under, make sure it's reciprocal, make sure these sorts of things are fair. If you can be fair for people, people want to work there.
All right, thanks.
Sure.
The next question, I think you've already addressed it. It's on citizen science. What might be opportunities in citizen science to contribute in your field, like helping out as a member of the community without proper credentials? I guess we just talked about
it's just basically see where the help needed tags are, and if it's something you think you can help with, start.
Yeah. Okay, that was the last question. I'll just ask one more. I know, like you told me, there's a free course that you developed for developers to improve understanding of open source software licensing. Can you tell us a little bit more about it and whether our students can benefit from it, for example, and where can they find it? Yeah.
So it's licensing basics. We can probably put it in the chat or something, or in the code. It's, if you Google Linux Foundation license, open source licensing basics for developers, something like that type of keyword, you'll show up. It's a free course, and it got developed because when I was still working at Freescale and working with these remote teams, I had to basically give them orientation and tell them, listen, these are the things you really have to pay attention to. And part of it's, okay, what's a license? Why do you care about it? What types are there? How do you form a license statement in the software such that people can understand it? And how do you do your copyrights? And then your file notices and so forth. And so there's some best practices, and this just walks you through. It's probably takes about an hour to go through, and it's multiple choice to make sure you've listened and paid attention. And at the end of it, it will issue a certificate if you've passed through the course. So you can, it's something that you could sort of sit and take at home on a weekend, or one evening, or if the prof wants to ask the students to say, okay, and you do the licensing basics, if they can come and show them the certificate they've gone through the course, that's useful information, because open source is open source because of the license. And understanding your rights as a developer and understanding how you should contribute is pretty key. So just a second. I'm just going to
look
it up, okay? Open source.
Sorry, I put it in the Slido, so it's on the questions part. I found the link.
Ah, good.
So people on Slido should be able to see it there. But yeah.
And so,
So yeah, I guess if you Google open source licensing basics for software developers.
Sure. You want to show the screen with it right now. It's LFC 191 too.
All right.
You want to switch over. Yeah, and I basically worked with some lawyers, and I worked with some of the experts in the industry to figure out what the best practices were, and we just made it available because we want to make sure that the information is understandable.
Okay. All right. that ends the question period just on time, Kate. Thank you so much for your interesting talk and very interesting path. I think a lot of students in our co-op program are inspired by your story and your significant role now in Linux that most of us use, including us in astronomy.
Very much so. And thank you again, and hi to my friends back there. Sorry I can't come see you this summer, but I've got to go into a 2-week quarantine if I come across the border. So everyone stay safe, and wish I was there.
You keep safe. You're in the hot spot. Well, thank you so much. We really, really appreciate it. I wish I can shake your hand and give you a hug, but I can't. So I'd like to thank you on behalf of the Faculty of Science and all of us here in Winnipeg. We hope to see you in person at the earliest possible opportunity. So for now, big thanks. And I'd like to advertise our next speaker, who's also a computer scientist. From our faculty, Dr. Purang Irani, who's a professor and Canada Research Chair in Computer Science at the University of Manitoba. So we hope to see you also, Kate, next week, as well as our students and viewers online next Friday, July 24th. And also, I would like not just to thank Kate and all of our speakers for the series. I also give big thanks to our Faculty of Science SPOT support team, who is shown here, working behind the scenes to bring the series to everyone and make it accessible. So thank you very much. And last but not least, I just want to remind everyone that the talks are can be replayed on YouTube, and also they are all posted on the Faculty of Science YouTube channel. So feel free to revisit any talk you've missed this past several weeks. And we hope to see you again for the following Fridays throughout the summer until end of August. And follow us on all the social media for the Faculty of Science. So hope to see you next week. Until then, have a great weekend and stay safe. And bye, Kate.
Bye-bye.
Thank you so much. Take care.